Welcome, guys, to the next part of uh, chemistry chapter 3, metals and non-metals. In this part, we are going to study chemical properties of non-metals. So we have understood in detail what is the pattern in which metals react with different elements, right? And different compounds. And on the basis of that pattern, we created a series called reactivity series of metals. See, the chemical properties of non-metals or trying to understand the pattern in which non-metals react is not as complicated as metals or not as lengthy as metals. So here there will be very limited examples, and also this video will be comparatively shorter than the previous video, that is chemical properties of metals. So let's start by understanding what is the tendency of non-metallic elements. So non-metallic elements, they usually have 4 to 8 electrons in their outermost shell. So they have the tendency to accept electrons to complete their octets, or to accept electron to complete their outermost shell. So they not only accept electrons, they also have this tendency to share electrons. But if they accept electrons, they form negatively charged ions. They form negatively charged ions or anions, and therefore non-metals are known as electronegative elements. For example, nitrogen, oxygen, and fluorine can accept 3, 2, or 1 electrons respectively to complete their octets. So nitrogen, which has 5 electrons in its outermost shell, can accept 3 electrons and becomes nitride ion with a valency 3 minus. It gains 3 electrons. Oxygen has 6 electrons in its outermost shell and can accept 2 electrons to complete its octet, and it is known as oxide ion, gains 2 electrons. Fluorine has 7 electrons in its outermost shell, and to complete its octet it accepts 1 electron to become fluoride ion by gaining 1 electron. So this is a usual tendency of nonmetals. This is how nonmetals can be understood in more detail, and they are known as electronegative elements. Let's start by understanding the reaction of nonmetals with oxygen. Whenever nonmetals react with oxygen, they form, please note it down, they form acidic or neutral oxides. They can form acidic oxide as well as neutral oxide. It was not the case with metals. Metals, whenever reacted with oxygen, not all metals react with oxygen, but whichever metals react with oxygen, they form basic oxides, right? But non-metals, when react with oxygen, they form acidic oxide. The acidic oxide, actually they also form neutral oxide, but talking about acidic oxides, the acidic oxides dissolve in water to give acids, and these acids turn blue litmus red. So carbon reacts with oxygen to form carbon dioxide. Carbon dioxide further dissolves in water to form carbonic acid, which we have seen is a weak acid, and it is a part of your soft drinks, aerated drinks. Sulfur burns in oxygen to form sulfur dioxide. This sulfur dioxide, when dissolves in water, it forms sulfurous acid, H2SO3. Sulfur also forms an oxide, sulfur trioxide, with oxygen in special cases, which dissolves in water to form sulfuric acid. Phosphorus, when reacts with oxygen, forms phosphorus pentoxide. This phosphorus pentoxide dissolves in water to form phosphoric acid. And the acidic oxides of nonmetals neutralizes the bases to form salt and water only. So non-metallic oxides mostly, which are acidic, they can react with bases to form salt and water, that is, they can undergo neutralization reaction. But there are some non-metallic oxides which are neutral in nature. For example, sometimes carbon, when reacts with oxygen, that is limited supply of oxygen, it forms carbon monoxide, which is a poisonous gas. formed by incomplete combustion of a combustible material like wood or coal or something similar to that. Okay, this carbon monoxide is a neutral oxide. Hydrogen, when reacts with oxygen, it forms water, which is a neutral oxide. Remember the examples of neutral oxides. When these neutral oxides are treated with litmus solution, they do not change its color, neither blue nor red. No color change is observed. Then the reaction of nonmetals with water. See, nonmetals do not react with water or steam to hydrogen gas because nonmetals cannot give electrons to reduce the hydrogen ions of water into hydrogen gas. So generally, nonmetals do not react with water or steam. Reaction with acids. Non-metals do not react with dilute acids and therefore hydrogen gas is not liberated when non-metals are treated with dilute acids. See, they are completely opposite to in their property to metals. Therefore, non-metals do not displace hydrogen from dilute acids. For example, carbon, sulphur or phosphorus do not react with dilute acids such as dilute hydrochloric acid or dilute sulfuric acid to produce hydrogen gas. We have seen that hydrogen can only be displaced from dilute acids if electrons are supplied to hydrogen, and this property by which an electrons are supplied to any element are shown by metals because they can donate electrons easily, right? So non-metals, they are acceptor of electrons, so they cannot give electrons to hydrogen ions which are there in acid, and they cannot liberate hydrogen gas with acid, and they cannot react with acids. Reaction with hydrogen. Non-metals react with hydrogen directly under different conditions to form corresponding hydrides. See, metals also form hydrides, non-metal also form hydrides. For example, H2O, H2S, NH3, HCl, CH4, etc. are common hydrides of oxygen, sulfur, nitrogen, chlorine and carbon. H2 plus O2 in the presence of electric current, they give H2O. H2 plus S, H2S, N2 plus 3H2 gives NH3, H2 plus Cl2 gives HCl. They all have different conditions under which these reactions proceed. Reaction with chlorine. Non-metals react with chlorine to form covalent chlorides such as HCl, PCl3. PCl3 is phosphorus trichloride. CCl4, carbon tetrachloride. Okay. HCl, hydrogen chloride. Okay, so non-metals, they do react with chlorine and they form covalent chlorides. Covalent bonds are bonds which are formed by sharing of electrons. So hydrogen and chlorine gives hydrogen chloride in diffused sunlight, which is a gas basically. Phosphorus and chlorine. Phosphorus is a solid, chlorine is a gas, and it gives phosphorus trichloride, which is a liquid. Reaction with salt solutions. A more reactive non-metal displaces a less reactive non-metal from its salt solution, a property which is exactly resembling the property of metals. A more reactive metal displaces a less reactive metal from its salt solution. Non-metals also behave in the same way. We have a solution of sodium bromide and it reacts with chlorine. Now, the two non-metallic ions which are at war over here, which are at fight or competition over here, are chlorine and bromine. Out of chlorine and bromine, chlorine is more reactive. Since chlorine is more reactive, chlorine will displace bromine from its salt solution. So the outcome will be, we'll get sodium chloride and bromine will be displaced out. But in its place, if we react sodium chloride with bromine, no reaction will take place. That shows that chlorine is more reactive non-metal than bromine. Distinction between metals and non-metals. Now this marks the end of this part of the chapter. This was a huge part. I had to make 3 videos. We are on the third video and this video is going to be little short. But with this video, we are trying to understand. We just finished the chemical properties of non-metals and we are trying to understand that what we have studied till now. And no better way to understand that rather than studying about distinction between metals and non-metals. See, there is no sharp line of distinction between metals and non-metals yet. There are some distinctive differences. The main point of differences are summarized in this table. सबसे पहले electronic structure. Metals have 1 to 3 electrons in the outermost shell. Non-metals have 4 to 8 electrons in the outermost shell. Exceptions are hydrogen and helium, which have 1 and 2 electrons in their outermost shell. This is electronic structure. Physical properties. Metals are mostly solids at room temperature except mercury, which is a liquid metal. Non-metals exist in all the three states of matter: solids, liquid, and gases. Metals are lustrous and shiny, and they can be polished. Non-metals are usually non-lustrous except diamond, which is a very hard substance. Also, except iodine and graphite, they can be lustrous. Hardness. Metals are generally hard except gallium, which is soft, sodium, which is soft. Non-metals are comparatively soft. Metals have usually high densities except alkali and alkaline earth metals, which are light. Non-metals have usually low densities except diamond. Conductivity. Metals are good conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. Graphite is an exception because it is a good conductor of heat as well as electricity. Malleability and ductility. Metals are usually malleable and ductile. Non-metals are usually brittle. Brittle means they are not malleable and ductile. They just break on exerting force on them. They are weak. Nature of oxides, chemical property. Let's go to the chemical properties, very important. Nature of oxides. Metals form basic oxides, though some metallic oxides are amphoteric also, but non-metals form acidic or neutral oxides. Displacement of hydrogen from acids. Metals displace hydrogen from acids and from salts, only those metals which are above hydrogen in the reactivity series. Non-metals do not displace hydrogen from acids. Reaction with chlorine. Metal react with chlorine to form electrovalent chlorides, and non-metals react with chlorine to form covalent chlorides. Reaction with hydrogen. With hydrogen, only a few metals combine to form electrovalent hydrides, but with hydrogen, non-metals form many stable hydrides which are covalent. Covalent means, again I'm telling you, covalent bonds we are going to study in the next part of this chapter are bonds which are formed by sharing of electrons. Metals are electropositive in character because they donate electrons, and non-metals are electronegative because they accept electrons. Metals act as reducing agent. What do you mean by reducing agent? Reducing agent means they uh, accept accept oxygen, they donate hydrogen, or you can say they donate electrons. Because metals give hydrogen, they take away oxygen and they give electrons. That's why they are reducing agents. Why non-metals are oxidizing agents? Non-metals are oxidizing agents because they accept hydrogen. If somebody takes away the hydrogen from some compound, it becomes oxidizing agent because they donate oxygen. That's why also they are oxidizing, and they accept electrons. That's why also they are oxidizing agent. See, since metals are reducing agent, they get oxidized themselves. They are oxidized. And since non-metals are oxidizing agent, they are reduced themselves. वो खुद reduce हो जाते हैं. Okay, so the chapter is over. Now see, there are some solved examples and a very interesting quiz can be set up in the live class, in the next live class which I'm going to take. So there is a huge assignment after this part which I'm going to share it with all of you just now. And what I want is, I want all of you, because I've taught you the chapter, I want all of you to complete this homework. It's a huge homework. I want all of you to complete this homework, and after the date of submission, whenever you submit, after that date of submission, we are going to have a live class in which we are going to have this quiz based on this chapter. So first we are going to have the quiz, and then we are going to address your doubts. Mostly from the quiz and the discussion which we have through that quiz, your doubts will be clear. Okay, so that's the purpose of keeping that quiz. Otherwise, I could have, discussed all those questions right away. But I don't want to discuss it like that. I want all of you live, and then I'm going to discuss it. So here we mark the end of first part of the chapter, metal and non-metals, and we have discussed a lot of important things. So in the next part, I think we have two more parts left, and in those parts we are going to study more about metals and non-metals, and what kind of bonds they form, how do they form those bonds, and we are also going to study about extraction of metals, which is a very exciting and interesting topic. Okay, so I'm going to see you in the next class, in the next live class, and after that my next video will come out. Okay, so till then, please complete your homework properly. That's my advice to you. Okay, so I'll see you in the next class. Bye bye.